Alright, so continuing with section 13.5, these are more double angle identities, but we'll also be able to see some of the other strategies. So let's do 43. So sine of 2 theta, there's an identity for that. It's this one right here, and we're squaring it. So that means sine of 2 theta is this, and it needs to be squared, and it's equal to 2 cos squared. So if you square 2, you get 4. If you square sine and cosine, you get sine squared, cosine squared. Let's subtract this and put it on this side right here. So it means the right side is now equal to 0. And this strategy we can use as the greatest common factor. So what's the greatest common factor for 4 and 2? That would be 2. How about for the trig functions? They both have a cos squared. So if we pull a 2 cos squared from that first one, we would get 2 sine squared. If we pull a 2 cos squared from that one, we just get 1. So now we need to move this over for a sec. Oops. That's not what we wanted to do, so I'm just going to move this to the other side. Okay, so now what we can do is we can set each part of this equal to 0. So 2 cos squared equals 0, and 2 sine squared minus 1 equals 0. So let's start with this one. We'll divide by 2. You get cos squared equals 0. When you square root, you get cosine equals 0. And where does that happen? Well, here's the unit circle. Cosine is the x-coordinate, and the x-coordinate equals 0 right here at 90 and right here at 270. So that means for this our two solutions will be theta equals 90 and theta equals 270. Those are two solutions coming from there. Now let's solve this one. We'll add 1 to both sides. 2 sine squared equals 1. Divide by 2. Sine squared equals 1/2, and then we'll square root both sides and put a plus or minus in front. Now let's fix this a little bit, because some people get confused and say that, well, that looks like 1/2. It's actually the square root of 1/2. So the square root of 1 over the square root of 2, if you rationalize that denominator, you would get plus or minus root 2 over 2. And hopefully you recognize that the sine of 45 is root 2 over 2. So our reference angle here is going to be 45, but remember, sine has to be positive or negative radical 2 over 2. So let's figure out where that's going to happen. So we're going to have 4 reference angles of 45 here and here. Those are where sine will be positive, because remember, all students take calculus in the first and second quadrant. Sine is positive, and in those fourth quadrant angles too. So this solution will be 45, we already said. This angle right here is 180 minus 45, because that reference angle is 45. That's going to be 135 degrees. Okay, this angle in the third quadrant is going to be 180 plus 45, and that's 225 degrees. And then finally, in the last quadrant, in the fourth quadrant, it's 360 minus 45, which is 315. So we have 4 solutions coming from there: 45, 135, 225, 315. And these answers are all given in radians there, but those are the 6 answers we had. We had 4 answers coming from one side and 2 from the other, and those are those right there. So this is 45. What was the other one? 135 is right here. Of course, it's fine to leave these in degrees. 225, where is that one? 225 is, I think, this one right here. That's 225. That's plus another 90. And then finally 315 is right here. And this one is 90, and this one was 270. So those are our 6. And that's generally the most solutions you would have. I can't really think of an example that comes to mind off the top of my head where you have more than 6 solutions. Alright, let's do this one right here. So again, this one is easy in terms of the double angle, because we only have one choice for sine. It's supposed to be a radical 2 right there, negative radical 2 cosine theta equals, and then this right here, the identity for that is 2 sine cosine. Let's put this on the same side by adding it to both sides. So that's going to be 0 is equal to this. And then you can see here's the strategy again. The strategy for this one is the greatest common factor. So what they have in common, I don't want to confuse you there, that's the dividing line. That radical only applies to the 2, not to the cosine. The greatest common factor right here is cosine. They both have a cosine. That's the only thing they have. So let's factor out a cosine. If you pull one out from here, you would be left with 2 sine. you pull a cosine out from here, you're left with radical 2. It's a plus radical 2. So how can we make this 0? We can set each part equal to 0. So cosine equals 0 here, and 2 sine plus radical 2 equals 0 here. Let's start with this one. We'll subtract radical 2. So we'll have negative radical 2, then we'll divide by 2. So we'll get sine equals negative radical 2 over 2. Well, remember in that last problem we found out that that angle is 45. Now we only need to be concerned with where sine is negative. And sine is negative in these two quadrants. So if we look for these two 45s, we actually kind of did this on the other problem. This angle here is 180 plus 45, which is 225. And this angle here is 360 minus 45, which is 315. So those are two solutions, 225 degrees and 315 degrees. And then our other two solutions are going to come from right here. Where is cosine 0? Cosine is the x-coordinate, and the x-coordinate is 0 right here at 90, and right down here at 270. So 270, 90, 225, and 315 are our four solutions for that one. And I'm sure they're going to give us to us in radians, but those are right. 90, 225, 270, 315. Those are these four things right here are those except in radians instead of degrees. All right. Here's the next one. Well, okay. Now this is a new strategy that we haven't seen before. These are not double angles anymore. So going back to our sheet, this is a half angle strategy 2. How did I know it was a half angle? Because this right here is a half angle. It's theta over 2. Okay, so let's plug that in, and here's the thing, theta over 2, we're solving for everything in this range, so we don't have to worry about whether it's going to be positive or negative. It doesn't really affect us because we're dealing in all four quadrants here, so we don't have to worry about that. Negative cosine equals negative 4, and then I'm going to replace cosine of theta over 2 with this thing. And like I said, we're going to ignore the positive or negative, because that's going to be taken care of by the fact that we're going everywhere from 0 to 360, so everything will be covered. Okay, so first thing, and we kind of did this in an earlier chapter, we want to get rid of everything except for the radical right here. So everything needs to go on the other side. So we'll subtract that 3 over. Move this out of the way again so we have more space. As these problems do end up taking up quite a bit of space. So we're going to have negative cosine minus 3 equals this right here. And then the idea here is that we're eventually going to have to square both sides. We don't want to do that until everything's cleared away. So I'm going to clear away this negative 4 also. And let's just clean up the left side a little before we start to square this. Actually, you know what, we could square that before that point. Let's do that instead. Let's not divide by negative 4 here. Let's just square it with the negative 4, because that way we won't have to square any fractions on the other side. Okay, so how do we square this? Well, again, why are we squaring it? Because this whole thing is under a radical right there, so you want to cancel that out. So we'll square both of these. Okay, squaring this side is like multiplying negative cos minus 3 times negative cos minus 3. Negative cos times negative cos is cos squared. Negative cos times negative 3 is positive 3 cos. This is also positive 3 cos. And then negative 3 times negative 3 is positive 9. So this whole thing on the other side becomes cos squared plus 6 cosine, because 3 cos plus 3 cos is 6, plus 9. Okay, what does the other side equal? The negative 4 squared is positive 16. And then this whole thing squared, those cancel, and we're just left with what's under the square root, so 1 plus cos over 2. Okay, now from this point it's not too bad. So 2 goes into itself once, and it goes into that 8 times. And let's distribute that 8. So 8 times 1 is 8. 8 times cosine is 8 cosine. And we still have the left side unchanged. And now, of course, we're going to put everything on one side. So we'll move the 8 over, and we'll move the 8 cosine over. And now this is going to give us strategy 4 on this sheet, which is factoring a trinomial. And you'll see that in just a sec. So these go away. This whole side is equal to 0 now. You have cos squared. 6 cosine minus 8 cosine is minus 2 cosine, and 9 minus 8 is 1. So this factors. What numbers multiply to 1 and add to negative 2? Those would both be negative 1. And how did you get the cos squared? You got it by doing cosine times cosine. So actually notice this is, you can actually write this a little bit more compactly. It's just cos minus 1 squared. So we only have to solve really one equation right here. So we need this thing to equal 0. And we can do that by adding 1 to both sides to solve this. Cosine equals 1. Cosine is the x-coordinate. Where does the x-coordinate equal 0 on the unit? Sorry, where does it equal 1 in the unit circle? Because that's what we're looking for. The x-coordinate equals 1 only right here, only at 0. So that means theta is equal to 0 degrees. So all of that work just to show that theta equals 0. And it's not a bad idea to check by plugging that back in. This is pretty easy to plug in. So let's test it. So the negative cosine of 0, if we remember we got a solution of 0, so negative cosine of 0 degrees, well, cosine of 0 degrees is 1, so that becomes negative 1. This right here, this also is going to be 0, because 0 over 2 is 0, so we'd have negative 4 times cosine of 0 is 1, so negative 4 times negative 1 is negative 4, plus that 3, negative 4 plus 3 is negative 1, and that works. It does check out, so 0 turns out to be our only solution right there. Let's take a look at this one. So again, here's our identities. I'll move these off so we can see them. Those are identities right there. And all we're going to do, this one looks like it won't be quite as labor intensive. We'll just substitute in the identity for cosine right here. That's equal to negative cosine. Okay, now how do we get rid of the radical? We can just directly start by squaring both sides. And sometimes you need to check solutions because you can get an extraneous solution when you start squaring things. So we'll always start checking our solution. I said sometimes you check them, sometimes you don't. Whenever you're squaring both sides of an equation, you should check. So radical and squaring, those cancel each other out, leaving us with what's under the root. And then negative cosine squared, negative cosine times negative cosine is just cosine squared. So to get rid of this 2, let's multiply both sides by 2. And so we have 2 cosine squared is equal to 1 plus cosine. And let's move everything onto one side so it can be in standard form. So we'll have 2 cosine squared minus cosine minus 1 is equal to 0, and that will factor. And so in order to get the 2 cosine squared, we must have had a 2 cosine and a cosine. In order to get the negative 1, 1 has to be positive, 1 has to be negative. And because this is a negative, the negative is going to have to get multiplied by the 2, not by the other one. So if that's confusing to you, suppose you had done it the other way, you can just check that by using FOIL. So 2 cosine times cosine is this. 2 cosine times negative 1 would be negative 2 cosine. 1 times cosine would be positive cosine. And negative 2 plus positive 1 is negative cosine. That's right here. And then 1 times negative 1 is negative 1, so that works. Okay, now let's solve this by setting each piece equal to 0. And we'll start with the right side first, so we'll add 1 to both sides. So cosine is equal to 1. Where does that happen? Cosine is the x-coordinate, and the x-coordinate equals 1 right here. So that means theta. I haven't been writing the thetas, but there's always a theta right there. Theta equals 0 degrees right there. So let's solve this other one right here. So we'll subtract 1. So 2 cosine equals negative 1. Cosine equals negative 1/2. Where does cosine equal a half? It equals a half at 60. But we need 60 in the 2 quadrants for cosine is negative, which is here and here. So 60 right here and 60 right here. What are those going to turn out to be? Well, this 60 right here is going to be 180 minus 60, which is 120. And then this other 60 down here is going to be 180 plus 60, which is 240 degrees. So we have 3 solutions, 120, 240, and 0. So let's check that. 120, 240, and 0. Okay, now I said 3 solutions, but actually I was wrong. Why is there only 1 solution there? And I said we have to check. So here's how we can check. They're telling us only 120 is right, 240 and 0 are wrong. So this is not hard to check. Let's check this right now. The reason you can get extraneous solutions is because we squared. So let's check 0, and let's check 240, because those are the ones. 120, just, you can take my word for it, you can try it. If you plug in 120, it will work. So let's check 0. So if we plug in 0 here and 0 here, we get cosine of 0 equals negative cosine of 0. Cosine of 0 is 1. negative cosine of 0 is -1. Those don't work. Okay. Again, why did this happen? Because of this step right here. When we squared both sides, we can introduce an extraneous solution. So we always need to check when we're squaring both sides. Let's check 240. So cosine, if we plug in 240 here and 240 here, cosine of 240 over 2, 240 over 2 is 120, and that's negative cosine of 240. Let's see, get this out of the way. So let's check that. Cosine of 120, well, here's 120 right here. That's like cosine of 60, but it's cosine of 60 where it's negative. It's in the second quadrant. So the cosine of 60 is 1/2, but this will be negative 1/2 because you're in this quadrant of 120 where it's cosine is negative. Negative cos 240. Well, 240 is down here, and 240 is also negative. That's going to have a reference angle of 60, so that's going to be negative cosine of 240, and cosine of 240 we just said is like the negative of cosine 60. But notice negative times negative will be positive. That's going to be positive 1/2. Positive 1/2 does not equal negative 1/2. So it is important to check and make sure that we get the right things. If we had plugged in 120, it would work for both. All right, let's do a couple more of these half angle identities here. So this one right here, we keep needing to move this over so we don't have it get in the way. Okay, so here, the only difference here is they're asking us to solve from 0 to 2 pi, so that means the answers they're going to give us are in radians, and we're going to need to check because we're going to have to square both sides. So first, let's start by moving all this stuff over, since we know that we're going to have to square, and we don't want to have to square with all this stuff on the one side. So we'll have negative 4 cos theta over 2 equals negative 3 minus 2 cos theta. Okay, so that's negative 4. What is cos theta over 2? It's this right here. It's that identity. So we'll plug that in. 1 plus cos over 2. And then we have this right here. Then what do? We end up having to square both sides. So we'll do that. Square this side and we'll square this side. Okay, squaring and square rooting cancel, and the negative 4 squared is just 16. So 16 times that thing under the root. And then this thing, when you FOIL it out, it's negative 3 minus 2 cos times negative 3 minus 2 cos again. When you FOIL that out, you're going to get 9. Negative 3 times negative 2 is plus 6, so it's going to be plus 6 plus another 6 would be plus 12 cosine. And then negative 2 times negative 2 is positive 4. Cosine times cosine is cosine squared. Okay, so let's just start to clean this up a little bit more. So the 2 becomes a 1, and the 16 becomes an 8, and then we'll distribute, so we'll get 8 plus 8 cosine. And then we still have this thing on the other side. And we'll put that in standard form in just a sec. So let's subtract the 8 and subtract the 8 cosine. So that whole thing becomes 0. Subtract the 8 from here, that becomes a 1. I'm just going to put it at the end here. Subtract the 8 cosine, that becomes 4 cosine. And then I'm going to put that 4 cosine squared in front here. Okay, so this now can, this can actually factor right here. And we want numbers that multiply to 1 and add to 4, but the only difference is that's a 4 cosine squared in the front. So if I put cosine times cosine, that's not going to work. That's going to give me 1 cosine squared. So you could use the swing method here. You could swing this over. Let me just do it with x's instead. So pretend this was 4x squared plus 4x plus 1. Swing this over. You'd have x squared plus 4x plus 4. What numbers multiply to 4 and add to 4? That's 2 and 2. So x plus 2 times x plus 2. Where did the 4 go? It's in here, so that means I get it out by dividing it. So we have x plus a half times x plus a half. And I'll take this 2 and swing it in front. So we have 2x plus 1 times 2x plus 1. So that means this is going to be 2 cosine plus 1 times 2 cosine plus 1. That's called the swing method. And this one is not hard because this is really the same thing. It's 2 cosine plus 1. The whole thing squared is equal to 0. So we need this thing to equal 0. So let's do that. We'll subtract 1 from both sides. We get negative 1 equals 2 cosine. Divide by 2. Oops, need some more space there. So divide by 2. So those will cancel. We'll get negative 1/2 is equal to cosine. The angle that has a cosine of 1/2 is 60 degrees, but it's 60 in the places where cosine is negative, and cosine is negative in these two quadrants right here. So we need 60 right here and 60 right here. This one is 180 minus 60, which is 120, and this one is going to be 180 plus 60, which is 240. So our two solutions should be 120 and 240, and I think they're probably going to give it to us in radians. Oh, you know what? Actually, I shouldn't say two solutions. We need to check. So let's check 120 and let's check 240 because we might not have two solutions. We might have one. So we'll check 120 here, and we'll check 240 right here. Let's start by checking 120. So we're going to plug in 120 for both of these. So 3 minus 4 cosine of 120 over 2 is 60. So minus 4 cosine 60 plus 2 times cosine 120. I guess it's going to be 3 minus 4 times cosine of 60 is 1/2. Cosine of 120 is negative 1/2. This is going to be 3 minus 1/2 of 4 is 2, and 2 times negative 1/2 is going to be negative 1. So 3 minus 2 minus 1 equals 0, and that's what it was supposed to equal. The other side was supposed to equal 0. So 120 is a real solution. Now let's try 240. So this is, I should have written equals 0 right here. So 3 minus 4 cosine, now we're plugging in 240 right here. So 240 over 2 is 120, plus 2 times cosine 240, that should equal 0. Question mark because we're not sure yet. So 3 minus 4 times cosine of 120 is negative 1/2. Cosine of 240 is also negative 1/2, so let's check this. 3 minus negative 4 times negative 1/2 is positive 2, and 2 times negative 1/2 is negative 1, and this right here, that equals 4, it does not equal 0. So 240 is an extraneous solution. That means 120 is the only valid one, and 2 pi over 3 is 120, just in radians. Alright, let's try this one. I think this might be the last double angle identity. We'll try this right here. Alright, so in this case, let's just move the cosine over so we can easily square things. And then this I'll substitute for the identity. So 2 times this, here's the identity for cosine of theta over 2. And then this other side is going to be 1 plus cosine. We will square both sides, because that's the only way we can get rid of the radical. So we'll square both of these. And if you square the left side, 2 squared is 4, and that thing in the root, those cancel when you're just left with 1 plus cos over 2. That becomes a 1, and that becomes a 2. When we distribute 2 right there, we would get 2 plus 2 cosine equals, and then see what the right side is. When you FOIL this thing out, you have 1 plus cosine times 1 plus cosine. When you FOIL that out, it's going to be cosine squared plus 2 cosine plus 1. Okay, now all we need to do is, this problem is got a lot of work on. I think this is from the other problems. Let me clear this out right here. And obviously part of the challenge here is just giving yourself enough room to work. Okay, let's finish this by subtracting everything to one side. So we'll do the minus 2 here, and then we will do minus 2 cosine. That's nice because these disappear. It makes things easier for us. So 0 equals cosine squared. 1 minus 2 is 1, and that's a difference of squares right there. Cosine squared is cosine times cosine, and 1 times 1 gives us the minus 1, and then we have a plus and a minus right there. So now we need to solve both of these, and also we need to check. So I'm going to solve it over here so we don't get in the way of that other problem. So cos plus 1 equals 0, and cos minus 1 also equals 0. So let's subtract 1 right here. So cosine equals negative 1. We'll add 1 right here. That means cosine equals positive 1. Where does that happen? On the unit circle, cosine is the x-coordinate, and the x-coordinate is positive 1 right here at 0 degrees, and it's negative 1 right here at 180. So those are the ones that we need to check. And again, why do we need to check it? Because we ended up squaring both sides. So let's check 0 degrees, and let's check 180 degrees. And I imagine that one of these is probably going to be extraneous. So Let's start with 0. If we plug in 0 here and here, we would get negative cosine of 0 plus 2 cosine of 0 over 2, which is 0. And the question is that equal 1? So cosine of 0 is 1, so that means this would be negative 1. Cosine of 0 is 1 also. So negative 1 plus 2, that does equal 1, so that one checks out. Let's try 180. So we'll plug in negative cosine 180 plus 2 cosine 180 over 2, because remember we're plugging into theta over 2. 180 over 2 is 90, and the question is, does that equal 1? So cosine of 180 is negative 1, so that's negative negative 1, which is 1. Cosine of 90 is 0. Hold on, let's make sure there's no mistakes here. Cosine of 90, what is cosine of 90? So in a unit circle, the x-coordinate and 90 is 0. So just thinking out loud here. So 2 times 0 is 0. So actually both of these turn out to work, unless we made a mistake. No, we didn't make a mistake. So 0 and 180, and that pi just stands for 180 right there. Alright, last one for this video, and then we'll finish the practice test in the next video. So this one is a totally different strategy now. We don't have any double angles or half angles, so we're not using strategy 1 and 2. It's going to be one of these other strategies right here, either a GCF or a trinomial or a Pythagorean identity, or squaring both sides. So the first thing to do is, it's always nice to put everything in standard form. So let's make one of these sides equal 0. This one is easier to make 0. And what's nice about this is now these things cancel, so we don't actually have to deal with that. So negative 2 tan cosine plus rad 3 tan. Which strategy is this? Well, they both have a tan, so that means there's a common factor of tangent that we can pull out. Okay, when we pull out a tangent from this one, we were left with negative 2 cosine. And we pull out a tan from this one, we're left with plus radical 3. And that's it. So now we need this to equal 0, so we can split this down the middle and make tangent equal to 0. And we can also make this thing right here equal to 0. Okay, let's start with this side. We'll subtract radical 3 from both sides. So we get negative 2 cosine equals negative radical 3. We'll divide by negative 2, which that was already supposed to be a negative 2. So cosine equals, the negatives cancel, and we're just left with radical 3 over 2. Where does that happen? It happens when theta equals 30. So cosine is positive in 2 quadrants. It's positive in the all quadrant, and it's positive in this 4th quadrant. And in both cases, we need a reference angle of 30. So this one is 30. This other one right here is going to go all the way around except for that last 30. So 360 minus 30, which would be 330. So we get 3, 30, and 30, and what's nice is we don't have to check these this time because we didn't square both sides. And then the other possibility is when tangent equals 0. And tangent, here's an easy way to tell. Tangent is the slope, because tangent is sine over cosine, and on the unit circle, sine is the y-coordinate and cosine is the x. So tangent is y over x changing y over changing x. That's another name for slope. So if you look at this equation, the slope is 0 right here. And it's also 0 right here. It's 0 at 0 degrees, and it's 0 at 180 degrees. Okay, if you're not sure what that means, or that explanation wasn't clear, then an easier way to do this is just in your calculator do inverse tan of 0, and you get at least one of those angles right there. And I'm just trying to recall if inverse tan is going to give you the other one. Let's check that right now. It's slipping my mind how some of these calculators are programmed. So inverse tan of, let's make sure we're in degree mode, by the way. Yes, we are. So second tan, that's inverse tan of 0, should give us 0 degrees, and it's only going to give us 0 degrees, so we also have to look where tangent, yeah, I mean the slope thing that I just mentioned is probably the easiest way to do it, because it's only giving you one solution, so 0 and 180. And another way of thinking about this is because tangent is sine over cosine, the only time this is going to be 0 is when sine is equal to 0. Sine is the y-coordinate, so where does sine equal 0? It equals 0 right here, because that y-coordinate is 0, and it equals 0 here. That's another way you can tell. So we have 3 solutions, 0, 30, 0, 180, 30, and 330, which is 4 solutions. So 0, 30, 180, and 330, there's how it works. Okay, so in the last video, we will do the last couple of problems in 13.5.